Hey guys, welcome back to another lesson. This is the continuation of transformations, and today we're going to talk about translations. Now, if you remember from the previous video, that a reflection is when you take each point of a geometric object and you measure its distance to that line of reflection. And then whatever that distance is, you match it on the other side. Well, a translation is to take every point and move it the same distance. Okay, with a reflection, it wasn't always like that. It just depended on how far it was to the line of reflection. Okay, an official term, definition, we have a translation, sometimes it's called a slide, all right, is a transformation that moves all points of the original figure the same distance in the same direction. Okay, now, a couple notations. First one, we could have what's kind of almost like a function notation, okay, from your Algebra 1 days. What this is telling me to do is to take every x-coordinate and add 2. And this is telling me to take every y-coordinate and subtract 3. Now, if I were to just draw a quick xy plane here, okay, that's telling me to move all my points to the right 2, because that's where all the positive x values are, because you're adding 2. You're going this direction. And then, because we're subtracting 3 to the y-coordinates, then we're going to be moving all my points down. So to the right by 2 and down by 3. And that's another way you can write it. You could just say it in a directional approach as well. We could write it what's called vector notation. Okay, a vector is, well, technically a vector, even though it's probably outside the scope of this class, but a vector just comes down to this. It's a direction that has some sort of magnitude. Okay, so it's pretty much telling you the direction of where something's going. That's a very, very basic term for it. And you can see the difference. One, they changed the brackets out, the parentheses, to these inequality symbols almost, right? And they took out the x and y's and just looked at the numbers. Both of these notations imply the same thing. You're going to move every point to the right 2 and down by 3. And that's a translation. A good example of this, if you're a fan of like stop animation, Tim Burton made a lot of movies with this. Nightmare Before Christmas, okay, that's one good example of it. If you've watched Rudolph the Red-Nosed Reindeer, okay, Wallace and Gromit, another great example. And stop animation is pretty much moving a character just slightly, taking a picture of it. Move it slightly again, take another picture of it. And by the time you keep moving the hand and you put all those pictures together, it gives you that motion of you like waving your hand. Okay, so that's what those movies were doing there. So translations, it could be seen in the movie business. How about that? And reflections. Let's don't leave reflections out. And rotations. That'd be the next lesson. But anyway, I think I'm getting off task here. Let's actually talk about this guy. Let's do some examples. I got my handy dandy overhead projector. And here's our first example. How's that for a nice segue? Pretty cool, huh? Okay, I have this quadrilateral right here, and I have the points listed off to the side, and I highly encourage you to pause the video so you can graph this. And what we're going to do, it's right up here in the corner, okay? This is written in like a function notation. I have x minus 3, y minus 4. Now, I'm going to write this in words as to what this is asking me to do. So this is telling me to move all my points to the left by 3. And move every point afterwards down by 4. And that's because of the negative signs. Okay? Does that make sense? And actually, did I? Yeah, I did that right over there. Sorry. Off track here. So literally, let's do that. Okay, so here's k. So I'm going to move k to the left by 3. 1, 2, 3. So it's over here. And I'm going to move them down by 4. So 1, 2, 3, 4. So here is my new point. This is where k prime is now located. Let's do the same thing with the other points. So j, I'm going to move to the left by 3. Move it down by 4, so J prime is located at the origin. Line, wow. Point L, I meant to to say. We're going to move that to the left by 3. So we're going to be 1, 2, 3. And we're going to move it down by 4. So L is going to be located right here on the x-axis, is its new home. And then M, I'm going to move to the left by 3. Okay, so that's going to move me to this point here. And then I'm going to move it down by 4. Okay, so that puts me right here. So there's my new M prime. Connect the dots. Here it is. Okay. Give me a moment. Give me a second. There we go. Remember, the prime marks indicate which is my image and which is my pre-image. My pre-image, this is a great review of the previous lesson. The pre-image is what you start with. The image is what you're left with. And there's my translation. Can you see the difference between a reflection and a translation? Every point got moved to the left 3 and down 4. Okay, a reflection doesn't always have that because it just depends how far it is from your line of reflection. And that's it, guys. Okay, there's our first example. At times, some people might actually draw the vector itself. They'll put like an arrow just to indicate where it's going, the direction of it. You could actually draw this with some accuracy if you'd like, but I'm okay with this. All right? If you want to draw an arrow indicating the direction it's going, you can if you'd like. What do you think? Any questions? Not too bad of a transformation, right? All right. What else could we do with this? Well, let's say you didn't graph it. Let's say you want to know what the coordinates were instead. Can we still do that? Absolutely. In fact, I am so glad you asked. If I look at this guy right here, it's subtracting 3 and subtracting 4. So if I look at my J prime coordinate, the x coordinate would be 3 minus 3, which is 0. The y coordinate would be 4 minus 4, which is 0. I apologize for this. I don't know how bright it's showing up on the video when I do that. Look, isn't J prime right here at 0, 0? Okay. We could do the other ones too, right? K prime, if I subtract 3, I get 2 for the x coordinate. Subtract 4, I get negative 2. L prime would be at 4, 0. And then M prime would be at 2, 2. Once I have these done, then if you would like, you can draw it on your xy plane just to confirm. Either way, either graphically, take each coordinate and move it, or algebraically, do that with each coordinate point and then graph it. It's your decision. Questions, thoughts, concerns, dilemmas? You guys are always so quiet. I wish you could speak up for me. One more example. Okay, we're only going to do 2, and then my next lesson is going to be on rotations, which is going to be a little bit longer. There's some tricks I want to show you with rotations. All right, let's try this one. So just give me one moment. Okay, more than a moment. I need more than a moment. Next example, it's going to be a triangle. Here are the 3 points of the triangle. And I'm going to write it using a vector notation. Let me go ahead and graph these points for us. 6, there's A. So B's at 1, 1. 2, 3, 4. This is kind of like a slanted triangle. Might not be kinda, it might just be. Let's see what this looks like. I'm quite curious. we go. That's our pre-image. According to this, now I'm using a different notation, using the vector notation. The only difference between that and the original notation that we just looked at was just they got rid of the x and y. Okay? The -4, which is in the x coordinate position, is implying that I want to move to the left 4. Because that's where all the negative values are on the x-axis, right? It's moving us this direction. If I'm adding 4, it's getting us closer to the positive x values if it's not already in the positive x value region. The -1 means I'm going to move all the points down by 1. Okay? Now, let's try something different. I'm going to go ahead and figure out what the coordinates are. Okay? Using just this information. Now, I apologize for this. I hate going back and forth like it, but I think it might be a little easier to see without that glare. I'm going to add -4 to my x terms. So for a, I start at 2. If I add -4, I get -2. 6, I add a -1, I get 5. Now let's go ahead and do the rest. So this one would be a -3 and a 0. And then this one would be a -8 and a -2. All right? A little bit different. I'm just going to go ahead and plot those points. That's what it's going to look like after the translation. Okay? Let's try it out. Maybe. There we go. I hope that didn't break. That would destroy my heart. I would hate that. All right. Let's see. -2. There's A prime. -3, 0. There's B prime. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. There's going to be C prime. Can you see that sometimes, and don't feel like you did something wrong, the pre-image and image can overlap. It just depends on the transformation. I just don't want you to automatically assume you're incorrect if they start overlapping. Okay? That can happen. There we go. We're moving everything in this direction. So you could put an arrow if you'd like to indicate it. And that'll be it, guys. There's another translation. Let me just put a for instance. Okay? Let's say this was a 4 and a positive 1. We did negatives twice, so I just want to be clear on something. Because that's a positive 4, I'm adding 4 to the x-coordinates, which means I'm going in this direction. So this means go to the right by 4. The +1 is in the y-coordinate position, so I'm going to go up by 1. If that were the case. It's not in this example, but just to show you, if there were positive values, what does that mean? Okay, that means move all your points to the right 4 and up 1. And that's a translation. Okay? Remember, the key part for translation just means that you're moving all the points in the same direction, okay? Unlike a rotation or a reflection, okay? That's a little bit different. It just depends on some other factors involved. So that's it. We're done. Hey, not a bad. It's a very small video this time. Hopefully, I'll see when I stop it. Have a good day, guys. I will see you all in the next lesson.